Hey, good morning, students. And today we'll be working on algorithm related to random forest, all the examples techniques. And before that, you have to understand a very simple technique, but very powerful. It's called backing. So what is backing? Well, firstly, backing is actually a technique called bootstrapping. So what is bootstrapping? So bootstrapping is basically the idea that we sample m times with replacement from the original training data and try to repeat this process b times to generate b bootstrap training data set d1, d2, and d until db, right? And we train these B trees using these training data sets. So we're treating this subset of the data sets independently and then join them later on, right? So if we perform this bootstrapping process, and then later on, maybe we take some majority, so averaging the prediction, we call this bootstrap aggregation or something called backing, all right? So how does this link with something we have learned in the past, that is decision trees? Well, we learned that in decision trees, trees tends to be overfit because trees has a very rigid structure in predicting something. But we can address that by having multiple trees. But the question is, how do we have multiple trees if each of the tree will have the same data set? Then each of the tree will predict the same thing anyway. So the idea is that we can perform something called bootstrap data sets in order to create different versions of the data sets. And then the trees can see different perspective of the data sets and hence different predictions. But we assume that by doing that, we can, when we do the average of the results or the majority of the results of the prediction, we can get a rough idea what would be the most likely prediction out of those trees, hence reducing the overfitting of each individual trees, right? So very, very splendid idea and very simple as well. So let's take a look at this example. So let's say we have a training set of, let's say I have 4 examples and I have 2 features. Here it looks like I have X1 and Y1, even though this is Y1 is actually, I would say this is a feature, right? So they have 2 features, all right? And I have 4 data sets. And if I want to set into B equal to 3 by bootstrapping, this would be the D1, D2, D3, right? So I can randomly pick any of them, right? And they can repeat it, right? Because here I'm doing something called with replacement. So I can always pick any samples and replace it, right? It doesn't matter. The algorithm does not say that it cannot duplicate the samples, right? And here I can randomly pick 4, 4, and 3, sample 1, 1, and 2, and 2, right? And this is called the 3 bootstrap data sets, right? And then what do we do? Well, we just create a decision trees for this, create a decision tree for this, and decision tree for this. And then we average the prediction results, we get the final results, right? So that is the whole idea of backing. Well, you may wonder, like, what if I don't do something called with replacement? Can I do something called without replacement? And that is yes, and it's called something called pasting, in which once you use sample 1, you can use sample 1 here, right? So you only have 3 to randomly choose, and you can choose 4. And if you have 1 and 4, you cannot choose 1 and 4 anymore. So you can only choose 2 and 3, right? So that in that case, it would sound like in the pasting scenario, there could be a likely chance that you can have the equal number of samples as your original data sets, right? Great. So that is the ideal. But from my experience, backing is more common. So I think we will stick with backing. All right. So here, let us take a look at the code. I have prepared a super simple data sets. That is our iris, our usual guy. But now let us try to implement and see how it works, right? So what I'm going to do is first we're going to import something, right? Define some parameters, and then define our subsampling, but basically bootstrapping, right? And then we're gonna fit each tree, and finally we're gonna make some predictions. All right, great. So let us import something. So I'm gonna do this really quickly. This time we're not gonna actually implement this from scratch because we already did this in the previous tutorial. So we're just gonna borrow sklearn, and then we're gonna do some random to make sure we can randomly pick something. And then we're gonna do something with stats too. And then finally, we're gonna do classification report. All right. So now we let us define some parameters. So I want 5 trees, right? And by the way, this number is all hyperparameters, so you don't have to really worry too much. And then that is x train, so mn equal to n, and bootstrap. We're gonna set the bootstrap ratio into 1, and we're gonna talk about this guy in a second. And tree params is equal to max depth 2 criteria Gini. So we're gonna use Gini to split our tree, and we're gonna do sample split equal to 5. So at least if you want to split, we must have 5 samples in the node. All this thing is not really is trivial for this tutorial. It's just some numbers that I set it up, so you can modify accordingly. It's not really the essence of backing. All right, so for in range B. All right, so now we have that number of trees. So we have 5 trees with this given parameters. All right, so that is our list of models. And we'll be also saying that what would be the sample size of each of the tree. And that would be basically what I'm calling bootstrap ratio. And in that case, that would be X train. So if X train is, let us, why not we restart and clear everything. Okay. And we're going to run this. And let's say that is that. So we're going to use the entire 105 as the sample size of each tree, right? You can try to play around with this number. This is again another hyperparameters. And then what I'm gonna say is that examples is equal to np.zeros, b comma sample size n, and y samples equal to np.zeros, b sample size. All right. So usually for one data set is always m comma n, right? But here I have b of them, right? So now this has become so example is composed of all the data sets and b times. Same for y. We have usually the shape of y is m. So now we have b of them. All right. So now we can define the subsample. So we can do for I in range B, for J in the range sample size, and the index is simply randomly picked from this range. Sorry, that rat range, and you can say that. So this is a clearly with replacement. If you're doing it without replacement, then the code would be simply looping, or maybe you have a list that keep all the things that is not being used, right? Then examples I comma j is basically equal to x train that. Then y samples is nothing but ij equal to y train. All right. So now we have all this bootstrapping done in this very small code. It's perfect now. So now I think we are ready to. So yeah, I guess the code is just that, right? You just simply extract it and fill it accordingly. So now your x samples and y samples have all the. You have a b sample, b data sets of this m and n things. And now I think you can now actually do this predictions. And before I do this predictions, I'm gonna create a placeholder, right? And this is basically usually your prediction is y. So the shape is simply m of the tests, and you have b of them because each of the three will give you different predictions. So you're gonna say for I in comma model and enumerate models, y hat equal to model dot predict x test, and then finally you're gonna save this into y hat. All right, and basically you are saying that hey, the predictions for this sample for the first three is this, the second three is say that, right? So how do we actually get the final predictions? Well, we have for each of the sample we have b predictions, right? Well, we can just say, take the majority, right? Take the majority. Now we can just use something called mode, right? In the stats that you learned in high school. So you can say stats.mode, and we're gonna say that hey, we're gonna take these predictions, and we're gonna take the first number with the highest mode. And for those maybe you want to take a look at what does this return you, but this one will give you the array, and by taking this one, we make sure that we get the highest number. Yes. And finally, we're going to say that classification report, and we're going to take this y test and y hat, which already get the majority of all the predictions, and then you enter this, and I have some problem. Okay, so maybe just give me one moment. I think this min sample split, forget s here. So now I'm gonna just run this again, and np is not defined. So just give me 1 second. I have to restart and run all to run this code. All right, and okay, so I haven't do any fitting yet. So let me make sure that I did not. Okay, I think I forgot something here. So right here. So I have to fit each of the three first, right? Before making the predictions. So actually this one is this one. So I forgot to fit the tree, right? So now as I say for I, comma model, and enumerate models, and x equal to x samples I, comma. So that is the first tree, and then the y samples I. Actually, you don't really need this. I don't think you need this. And then you just say model.fit x and y. Right. The reason why I put the underscore in the front, so to make sure that it reminds me that not to use this variable, because it's simply it's an intermediate thing that you're allowed to fit this model, right? And then you loop this, and eventually you will have that number of models. And here you just loop the models to repeat. All right, great. So hopefully things should be fine. Great. So you can see that by doing this idea, you get pretty good results, right? And this is the beginning of idea called assemble, in which assemble is simply using multiple classifiers together to make a joint decision, right? And backing is one of the simple idea that you can do this, right? But later on, I will introduce something called random forest, which built up on top of backing to make it even more, even better, right? But anyway, thank you very much. That is it, and see you in the next tutorial on random forest. Bye bye.